Hi, and welcome to another episode of Kasper On BI. I'm pretty excited. Today, we're going to talk about AI, CoPilots, LLMs, all of these things. And I thought it's about time because we hear a lot about CoPilots, we hear a lot about AI, we hear a lot about all of these things, but I would really like to understand a bit more the tech behind it. How does it work? What does it do? What are all those CoPilots and how do they actually help us? Today, we're lucky to have Alex van Grootel with us. As you can hear by the name, he's a Dutch guy, but he doesn't live in the Netherlands. He lives in the US. He's an AI expert, and he works on the Fabric team, working on all of these amazing features that we are getting delivered. Not just Copilot, but everything AI. And today, we're going to learn from him. What is it? How does it work? What is AI? What more can we do with it? So I'm really excited about this, and let's go to the episode. Hey, Alex. I'm really honored to have you on the podcast. You're a PM on the Fabric team, so maybe you can do a little introduction of what you do at the company.
Yeah, thank you. It's very nice to be here, Kasper. Yeah, like you said, I'm a PM in the Fabric team, and there I sit on the data science team, focusing mainly on some of our generative AI features. So there's this new wave of large language models, and I try to make them as useful as possible for our Fabric customers. And specifically, what I work on is some of the data science copilots, but also we want to put the power of large language models in our customers' hands so they can build within themselves. And it's my job to sort of like frame how customers would want to solve problems with that, what that looks like, what is possible, how do we like think about this new technology, how do we de-risk it and figure out what it's actually good at or not, and how do we implement that responsibly, right? How do we make sure that it's going to be used in the right ways?
That makes a ton of sense. And so maybe you can share a little bit of how you got into AI, and because I know you're like in the heart of where it all is happening right now too.
Yeah,
where you live. So maybe you can share a little bit on that.
Yeah, that's a journey that's been going on for a while. Actually, I was at MIT in grad school doing this program called the Technology and Policy Program, where I was initially working on sustainability. I kind of saw that as the big problem of our time, and I was doing research in this material science lab that was focused on industrial ecology. But one of the things they were working on was trying to use AI to basically learn how to make better materials. And I saw that as such a fascinating new approach. And they were able to ingest all this information from millions of academic papers. And that just transformed the way I thought about how to solve problems. So I dove into that and learned very quickly that this is probably going to be a technology that's going to change a lot of things. And that got me working as a data scientist out here in the Bay Area for a couple of years over in a material science and AI company. And then I switched over to Microsoft, where I was working on their autonomous systems division. First, again, working as a data scientist, so very hands-on, doing fancy industrial AI kinds of things. And then there was an opportunity that arose with this new wave of large language models over in Fabric, and I needed a team to build some of their copilots. And that seemed very exciting to me. It's one of the big new waves in AI right now. So I kind of dove in there, and that's how I ended up here. So I've worked in a few different areas, both as a hands-on data scientist and as a researcher, and then now as a product manager.
That's pretty cool, yeah, because it's going from like deep like technology researching to now being able to, okay, how can we give that into the hands of like everyone? That's quite
absolutely.
That's quite interesting.
And it's very interesting to see like how fast that happens, right? Like a lot of the work that I was doing back even like 7 years ago was very hard to get these systems to do anything with text. That required a lot of deep knowledge and like very specific domain expertise. And it's funny that like once GPT-3 came out, like ChatGPT came out, I was able to revisit some of those old problems I had spent months on trying to solve, and it was just, you just type it into a text box and it's done. And in that time frame, right, like what used to take us like a team of PhD engineers and like PhD researchers is now just yeah, it's just largely solved.
Yeah, it's pretty interesting. And it's pretty interesting to see where it's going to go. I was just researching before we got on the call on what's the best heart rate zone to run in. And I was asking CoPilot to tell me what I should be doing. And they gave, first I was searching for it myself, and I was like, I couldn't really find it. And boom, immediately it would tell me exactly what I needed to know. So it was, yeah, it's pretty cool. Okay, so let's take a long step back, because most of the people that are listening today are people like myself with data warehousing background, analysis services, data modeling, all of these things. And the only thing we really know about AI is the old data mining add-ins that I was telling you before on the call, where you can do market basket analysis and forecasting on top in analysis services on top of small data. So what is AI?
Great question. First of all, you're not alone, right? I get asked this question a lot, and especially still in the circles where I'm in a data platform. Like even there, lots of people are still just curious and know very little about like AI. So great question. AI by itself is a pretty vague term that gets probably misused a lot. If you want to be very technical about it, just AI is just any like machine system that makes decisions in an intelligent way. That's maybe kind of a cheating question or a cheating answer, because then what is intelligence? But it's really like a system that is not living, as in it's not a human or a dog that can just make decisions for you. So if you take that, for instance, to if you can build a few simple like if-then statements, you know, if you're just saying like, well, let's imagine that I'm playing tic-tac-toe. I can build a system that says like, well, I'm going to start putting it in the middle. And then if my opponent puts it on the corner, then I'm going to put it over here. And if the opponent puts it in the center top, then I'm going to go over here. And I can sort of like make this entire decision tree. That is a form of artificial intelligence. Right? So that totally counts. Where things become a little bit more interesting is when we start talking about machine learning, which is probably something you've heard about, which is this idea that we, instead of having to program in these rules ourselves about like, this is, you know, the decision tree that you should use in order to make these decisions for tic-tac-toe or for any other problem, we get the machine to learn it themselves from data. And this is where this big wave has come from in the last like few decades that really has allowed us to make these artificial intelligence systems much better, because instead of us having to program that in, we get these algorithms to learn it. And that has opened up all kinds of new amazing use cases. So, yeah, have you heard of that dichotomy, the AI versus machine learning?
I think so. I think let me rephrase, because I think also, like, for example, my car, I have a Tesla. It is a bit different. In the regular car, they use, like, they program, okay, lane assist, what they needs to do when a car comes. But from what I understand, Tesla uses the input from everywhere else to determine what your car should be doing. Instead of programming, they learn, right?
Yeah, exactly. And that is a total game changer. So if you go back to like the 90s and the early like 2005 or so, even back then, people were still trying to hard code a lot of these rules. And then there were a few moments where people were just able to throw data at the problem and have this algorithm like figure that out for themselves, and they just started outperforming all other applications. That in many ways, I think we're still coming to terms with that lesson. Like there's still a lot of instincts that people have that they want to just sort of force some of their domain knowledge and their own rules on some of these systems. But and we're probably going to be talking about it a little bit later, like especially when we start talking about large language models, we can just like give volumes and volumes of data and have the right algorithm that can like learn from that. You can get to very almost magical seeming systems that are able to like, and Tesla works right very much in the same spirit of like, instead of like us having to try to say what is a road and what do we do in different circumstances, just say like, well, here's what a human did. Learn from what those rules are, based on what you see from the cameras. And that's, yeah,
that's pretty cool. So, okay, so let's dive in a little bit deeper, because that learning and the way that, like, after you've learned, it created a model. Is that what a model is?
Yeah, and I guess the word model gets very
Okay.
like used in many different ways, right? In this whole field. But with machine learning, that's exactly right. When we're talking about like, I have used some algorithm to learn to fit to some data, that the thing that has been fit is then the model. So in a very simple example, like linear regression, y is equal to mx plus c. It's probably something you might have like come across in your linear algebra or classes. That is a model data. There are many other kinds of algorithms. Some are more complex than others. But ultimately, once you sort of like take the model, use this algorithm to like fits these parameters to the model, you now have something you can go and deploy and use to make predictions. And right, and that, yeah, the model was the unit to talk about there. So anyway.
So you can train that model to do kind of whatever you want it to be. And so how do you control the, like you kind of set parameter, but how do you control the extent of what it needs to learn? Because I can imagine it can go wide, or it can learn more than you want it to learn, or something.
Sure.
Like this.
Yeah. Yeah. So like the main thing that you're going to be doing there is, you need to give it a goal. So you need to tell it like, this is what I want you to follow, right? So there'll be talks about like, what is your objective? What is your objective function? But you need to give it an explicit, like, if you have images of dogs and cats, I want you to predict, when these pixels come in, I want you to label this as a dog, and if these pictures come in, I want you to label it as cat. Right? So a human has to come in and actually like articulate that. And the way you do that like differs a little bit depending on the algorithm, but largely that's a big part of it. And then, so beyond the objective, the other big input to all of this is going to be your data, right? Like, what ultimately all this
the training,
comes back down
right? You train it.
Correct. Yeah. Yeah. So you have like some data and then that process of trying to fit your model to perform the objective function on your data is called training. And there's a few different paradigms that people think about in this. Like you have supervised learning, where you have examples of like, this is the true label. So classifying dogs versus cats is a classic example, but also things like forecasting. Like we have all this data from the last like 10 years. If you now want to predict for like the next year, like, that's another example that we take like the first few years and predict the next year, and then the next few years and predict the next year. We have examples. Sometimes you don't have those labels. That's unsupervised learning. That's a very different way of approaching it, where you might say like, I don't really care about making predictions about specific outcomes. I just want to see like, are there patterns in this? Are there different kind of use case, like different users in my user base that like, well, we have these like this cluster of users, we have that cluster of users, and it might be useful for us to think about that. But
and then, so you train it with data, and does the amount of data matter? If you feed it more and more and more data, it gets better, and is there a way for you to know, okay, now it's done?
Yeah, great. Both great questions. Ultimately, like that more data is usually better. Data quality also has something to do with it, as you would imagine. So, if you are forecasting, maybe market demand on some product you have, having data that goes back, 20 years sounds great, but sometimes it might be something that's structurally changed. Maybe the actual product changed, or the way you're marketed it changed. So like, if you don't account for that somewhere in your algorithm, that data might kind of skew things a little bit, right? And maybe like the underlying dynamics, which you're trying to kind of like figure out the trends for, have changed. And as a result, the older data might be less relevant and kind of skew or bias the data. So you kind of have to like do some, kind of learn through it. Are there outliers here? Do we need to remove that? But in general, yes, we always want more data. And then the second step is, do we need to remove some of or cut away some of that data, just to make sure that it's all relevant and high quality, and it's there's not too much noise in it and those sorts of things. And then in terms of like, how do I know how well it's working? That's often kind of like framed as the big problem of machine learning, right? So these models, they can be powerful enough that it can sort of like almost memorize the data. And the way that you want to get around that is you hold out some of the data that the model never sees. And you call that your test set or your validation set. So you train on some amount of your data. And then you say like, great, now I can predict on my data that I held out and compare the predictions with the actual values. And if those do well, then I know I have a decent model that has predictive power that is useful. And if they don't do well, then you might need to consider like, do I not have the right information? Do I not have the right data? Is there something else that I've set up in the way setting up this model? But that is sort of often the key part of these machine learning like projects and when you're training them. What do you consider in the test set? Like what data do you hold out? And how much trust do we have in those comparisons?
That makes sense. And then, so are there, like, in the life of a data scientist or people wanting to use these models, and are there a lot of models that are available? Like the majority of the people, who are using these models, will they actually be creating models themselves, or you can pick a lot of them off from the shelf and use them?
Oh, very much the latter, especially in the last decade or so. We've seen a big rise in like open source software and various other like software you can buy that makes it very easy. So with 2 lines of code, in Python you can import one of these algorithms and fit them to your use case. And I'd recommend for anyone who's interested is just to try that out. Like before you start learning about the statistics and like the math behind it, like it's often useful just to sort of like try it and learn by doing, and kind of get some sense of like, hey, how do I just fit this? And there are many tutorials online. We now have things like large language models and CoPilots that can help you like with all these sorts of things. And then once you're kind of interested, you can more about the technique, but it's simple to get started. Yeah.
And then, so as a data scientist, like someone in an organization doing some data science, you would think their main job is finding the right model and then applying it to their organization's data? Probably.
Yeah. In part. So when I was a data scientist, big parts of my job were to understand the business problem first and foremost, right? Like I think the instinct is often like, let me just go from the data and create a model and like just like ship it and like now it's good and great and we have this technology. Yeah. But usually most data projects fail because they fail to account for some nuance, right? There might be constraints that you may not immediately think about. Or it might not be really that valuable a problem. So people aren't really willing to change the way that they're thinking about it or their approach. So very much the first thing you should do is get acquainted with like, is this actually a problem? Is there a simpler way to solve this rather than using a machine learning algorithm? And then, then you go through the process of understanding the data, building a very simple baseline, trying to see if that by itself would actually like solve this problem or not. And then we can make it more complicated and add, deeper layers of sophistication. That as a data scientist, that's the point at which you would be like, we tried this out, but we didn't consider this key constraint that the business team is now telling me like is very important. So like I now need to like bring that into the algorithms and the models. And then there's a whole process of making sure it actually like will perform in reality, and move on. Right. So the actual building the algorithm is like or like building the model is like a small part of that larger process.
Yeah, and then I mean, there's a lot of parallels to like how we do. Like my background is BI. It's also like talk to the business the most important. Like otherwise, your DAX expression that you write, like you'll get a number, but is it the right number? Who knows? And second, probably does the same thing here. Like you can train the model on certain data, but how do you make sure that the data that you have in your organization fits like similar to the data that they have trained the model with? Like, how do you know that it's compatible?
Yeah, a great question. And this is, I can ask you the same thing, right? Like, how do you do that? How do you deal with that in like Power BI, or so like in business intelligence kind of like situations, right?
Probably the same as we were talking about before. Comparing to what you think the expected outcome is.
And I think ideally what you do is you try to bring out a solution and you iterate on it, right? And you kind of listen to feedback, and you probably have this explicit phase in your process where you say like, hey, here's what I think should work. Can we try that out? Will you use this? And listen keenly to the feedback that people will give you and say like, well, actually, like this doesn't work on these edge cases, or like you fail to account for, right? And like, okay, then we change our schema in your case, right? Or we change like some of the behavior of the model in like the machine learning case. Yeah, I think there's probably a lot of parallels that like a lot of the skills here are very transferable.
So one of the things, the two things that you mentioned, I don't have it in the script that I sent you, but like you were talking about performance and need to rerun. So, and we hear this a lot in the news, right? NVIDIA is like almost about to overtake Google, I think, in market cap because of all the CPUs that they need to ship. So this needs a lot of processing power. So how does that work? And why are these GPUs better than CPUs? I know it's a geeky question maybe, but I think we have geeky audience enough. So.
Oh, great. Yeah, no, I love this question because it's like, it's such a kind of crazy turn of events. So it turns out that one of our best algorithms that we have been able to come up with that deal well with large amounts of data is something called a neural network. There are many different kinds of flavors of neural networks. The big one that is sort of powering this latest wave are called transformers. But at the core of it, what a neural network really is just a bunch of matrix multiplications. So if you want to train a neural network, you need to multiply large matrices. So large, like tables of data, right? Like rows and columns of data that get multiplied by each other. It turns out that is very similar to the kinds of calculations that you need to do if you want to run graphics. So if you are playing a video game, exactly. Yeah. So if you're playing video games, what's happening behind, like in your computer, is that you have all of these matrices being multiplied by each other, and that allows you to calculate, like, the shadows and what the water looks like and what the grass looks like, and like if you change your angle and your camera position, like it gets recalculated all. So CPUs are not great at doing this kind of matrix multiplication, but GPUs, graphical processing units, are designed exactly for that. Initially, exactly to do like video game processing. And now it turns out they're also great at multiplying matrices for neural networks. So now if you want to have a very large amount of data on a very large model, you are much better off doing that on a GPU than a CPU. By like, I think it's like, a factor of like 100 or 1,000 or something like that. So it's like incredible speed ups. And we have this new big push about building these large language models, and the name large in the large language model is not to be understated. These things are massive. They won't fit on your laptop, or like they require a supercomputer to run. So improving the speed of training of that by a factor of 1,000 is very attractive, which is why we tend to use GPUs for that instead of CPUs. And NVIDIA, being one of the first players in this, like, have been able to see that trend coming for a while, and I think are in a great position now to sort of, ride that trend. Yeah, exactly.
All right, so you mentioned a few times, we're all waiting for this. We hear a lot about LLMs. What are those? What are they?
So an LLM stands for a large language model. When you say language model, really what you mean is something that can model language, meaning that it can generate text. Large, because these models are big. GPT-3 is about 175 billion parameters, I think, like off the top of my head. That's huge. Like I said, you need industrial grade computers and computer clusters, more like, to actually run that, never mind to train it. It probably cost OpenAI something on the order of like $10 million-ish to create. So yeah, these things are large.
And the idea of a... So what does it mean? Like, you say large and you talk about parameters, but like in the data land, does it mean, what does the large mean in this case? Like, large tables for me, like, okay, it's a lot of data. It's like a couple of terabytes of data sitting on disk somewhere. And is that the same large? Is the model large or is the data large? What is large?
Yeah, so the model is large, the data is large, and also the compute required to train the model is large, and they're all kind of connected, as you can imagine, right? Like, um, but usually when people talk about large language models, they really mean that the actual model is large. So before I was talking about, y equals m, mx plus c. There are two parameters in that model. Pretty straightforward, right? The parameters being m and c, and you need to fit that to your data. Now imagine I had 175 billion of those parameters. Yeah, that's a lot. So if you actually wanted to download like something like GPT-3, which you can't because it's OpenAI owns that and they don't make it public, but that would be probably a couple of gigabytes worth of like just raw numbers that are just all printed on some file format. So that for most machine learning models is considered to be extremely big. And it needs to be that big because they are basically trying to train it on the entire internet. They took most published books and all of Wikipedia and a whole bunch of articles and blog posts and Twitter and all the other things that you can think of. And they basically just said like, hey, given these initial few words, can you predict the next word? Right? This is where that language modeling comes in. The only thing that these large language models do is just predict the next word in a sequence. And it turns out if you throw enough examples of that, you can get very good at predicting the next word. And magically, almost as part of that, they're almost like this sense of understanding of these large language models. And they start being able to do things like summarization. And they seem to be able to talk about very many different kinds of topics, right? So that's sort of like the big bet that people are making right now. If we just add more data with bigger models, so therefore use more compute to train it.
You mentioned something like, so this model that they're training, when they started setting out with like GTP in the beginning, and so there's different versions of it. With every version that it comes, they find new features that they can use. Like you said, the summarization. Is that a find, or is that like did they design it like that?
No. So again, this is machine learning, right? So we don't design anything into this. We just give the model a task, or we set an objective function, predict the next word as well as you can, and then all these other things seem to just sort of like come out, like their emergence properties. So if you look at GPT-1, it's not really able to understand the idea of summarization very well. But if you go to GPT-3 and you give it some example text and you say, summarize this for me, it understands what it means to summarize and is able to just provide you with a summary. So in many ways, this is very exciting because it seems very powerful to suddenly get all these abilities that you didn't have to explicitly program into it, right? So that makes it a very general technology. You can write poems with it. You can like use it to create lesson plans. But in many ways, it's also maybe a little like strange and potentially scary to think of something that can just sort of spontaneously like generate new abilities, right?
And I think probably for a lot of people like me, my background is programmer, like C#, ASP before. It's you can look at the code and understand it. Like here, I'm trying to think like, okay, how does this work? So how do you find out that there is now all of a sudden summarization is possible? Like how do you know? Like do you program it and then ask it for something? So how do they figure it out?
Yeah, I think the interesting thing is that you have to treat this almost more as science than engineering. So just in the same way that we might probe like your body for, we might run some tests on that in terms of like, how does your biology work? If I give you this kind of drug, what happens? In a similar way, we kind of have to approach these AI systems with, if I enter this in, like what comes out the end of it? And is that something that's reproducible? And that way we do discover new abilities. As opposed to doing like software engineering, right? If I can look at a code base, I can reason through it, I can understand it. I can see like, well, these are exactly what it can do and what it can't do. That model doesn't exist yet for neural networks. Neural networks and most machine learning algorithms are notoriously kind of black box, meaning that it's hard for us to see what's going on behind the scenes. And there's a whole field of study called interpretability that tries to learn how neural networks work, but it's very coarse. It's very high level. So yeah, even now, like, GPT-3, GPT-4 have been out for a while, and we're still learning kind of weird new quirks that it's picked up and learned. So for instance, a couple of months ago, people learned, like, if I tell these models, take a big breath and then ask a question, they do better than if I were to just ask a question. As in, like, they can perform deeper reasoning. They can get more questions right. And that is such a strange phenomena, right? Like, can you imagine, like, talking to, like, software, like, 10 years ago, and you say, listen, you need to be very polite and, like, kind and understanding to your AI, and then it does better. It feels very foreign to me. But this is well demonstrated, and new kind of insights like that keep coming out, and I'm sure we'll learn more in the future.
Can you imagine what it looked like in 5 years?
Yeah, I often try to, but it's hard, right? Like, part of the problem here is that people don't really know, right? It's hard to predict.
Yeah.
The big,
Especially,
the big bet right now is just like, can we make things bigger and therefore better, right? So the only difference between, like, GPT-1, GPT-2, GPT-3, GPT-4, there's a little few differences in, like, the algorithms that people are using, but they're like fine-tuning differences. Really, the main difference is just how much data do we throw at it? How big are these models? So if we kind of continue the trend line, we think that GPT-5 is probably going to be significantly better again, and we kind of know how to build that. And now the GPT-6 maybe as well.
And then, so
we'll see.
GTP is like OpenAI, and of course we Microsoft can use that too. But like Google has Bard, or I think it has a new name now, but is it?
Yeah, Gemini.
Yeah, is it the same? The same idea?
Yeah, pretty much exactly the same idea. A lot of these labs and companies, they don't really publish, all the details. Facebook, for instance, has a Llama model that do publish the actual end model, so you can go ahead to, like, on the internet right now and actually download that, so you can actually have the raw model, and if you have the GPUs for it, you can run it yourselves. But they don't, for instance, tell you how they created it, right? They give some details, but they don't give you, like, the raw code. Similar with, like, there's a company in France called Mistral that came out with a great model, also very similar, right? Still neural network, still transformer, still trained on, like, very similar data like the internet, still just predicts the next word. Exactly how they did it, kind of unclear. But OpenAI has models, Anthropic has Claude. Microsoft is trying to work on, like, smaller language models. They're still pretty big, but instead of, like, 175 billion parameters, we're talking about, like, 1 to 3 billion or so. So they're called the Phi model, Phi 1 and Phi 2. But again, very similar architecture, very similar model, trained in very similar ways.
Yeah, and so let's turn now to, because those LLMs are used in CoPilots, right?
Correct.
That is what CoPilot. Yeah. So what are CoPilots in your words?
Yeah, it's a good question. I think it can be sort of, it's a bit of a fuzzy term, and people are still kind of like, the naming in the last year has evolved for a lot of these different, we call GPTs and agents and copilots. Yeah. But the spirit of a copilot is like an AI helper that will just help you do your tasks, right? So there's like there's the Fabric copilots, which we'll probably talk about later. There's the M365 Teams copilots. In Word now, there's a copilot. PowerPoint, Excel, there's all these copilots. And the general idea is that you can, in English, ask your questions, and it'll be able to, like, help provide some answers, maybe take some actions on your behalf. And it's just a generally useful tool to guide you through your tasks.
And they're all fueled by LLMs.
Yes, all of these examples are fueled by LLMs. I think in principle, you could come up with a copilot system that doesn't have LLMs, right? But you should think of most of these copilots as just being powered by LLMs. They're the only thing that is sort of generalizable enough to fulfill that copilot role.
Yeah, I can imagine. I mean, the first time that I really got to, like, of course there was GTP, but it didn't really, like, I didn't know what to do with it. The first time when I really started coming home for me is when I started using GitHub Copilot, when you can actually like enter some comments saying like, oh yeah, just I want to open a connection to Power BI, and like it writes the code for you. Like mind blown, you know, it's that's pretty cool. So, but there I kind of get it. Like in a lot of those Copilots, it is, there you can learn from a lot of code. Like if you've seen enough people writing comments like, okay, I'm going to open a connection string to Power BI, the next 3 lines are usually this code or like a mix. This is the common denominator, and this is what I'm going to return to you. And I think for many of the Copilots that even in Fabric that we have, and like Word Copilot, Teams Copilot, it all seems to be around like meetings where you have transcripts that, okay, transcripts, it knows exactly what it needs to do with transcripts, right? It can learn from the transcript, it can make notes for me, it can make recap. I love that feature being a PM, where in Redmond, all the meetings happen in the night, in the morning I wake up and Copilot tells me exactly, oh, this is what happened last night in all the meetings. Perfect for me.
That's great.
Pretty happy. So, but not everything is that easily, it's not all code, right? So how does that work then?
I mean, still in a very similar way, right? So the way that you should think about these large language models is that the only thing that they can do is just predict the next word, and they have sort of a general sense of your of the world because they've read the internet, right? It's like a decent mental model to have, but they don't really understand anything about your specific scenario unless you tell it to. So the way that these Copilots in general work is that if you ask it a question, it might just sort of have some information on the back end, or it might be able to look up similar files that you have written in the past, like via Word, or use Bing to go find relevant information. And then the idea is that it would add all of that information that it finds into what is called the prompt, which is sort of like the preamble that you would send to these large language models. And then these large languages will essentially read all of this and then predict the next word, and then take all that they just put out and go back and fill that back in and just predict the next word again. And you kind of repeat that process over and over and over again. So that is a useful way to kind of keep coming back to like, how do these Copilots work? Like at the end of the day, what needs to happen is you need to send some amount of text to these large language models and it'll predict the next word. And then the whole trick is, what information do we need to provide? What additional additional actions could we allow this thing to take? And if we want to take an action, it might say like, here's a special symbol, and then search.bing, here's my question, and let's wait until that comes out, and we'll feed the answer of that also back into our prompt. But then the magic of LLMs is just that they have a general, like a basic reasoning capability. So they're able to like take all this information from the various sources that the larger Copilot system has provided it, and then provide it with a reasonable thing to do, which might be generating code. It might be providing a summary or providing like the first examples of some Word document or email that you're writing. And how exactly does that work? Like, no one really knows, but it seems to be working pretty well.
Yeah, it does. Yeah, so is that also what is called generative AI? Generative AI?
Yeah,
is
so
the same?
Yeah, so this idea of like generative AI is kind of an encapsulating term of the fact that we've kind of hit this mark both with large language models, where we can generate text, right? So that's the generative part. And at the same time, there is similar but distinctly different technology. It's a bit more like a diffusion model, is sort of the classic example for images. So you might have heard of like Stable Diffusion or DALL-E. These are examples of like, I can provide some text and it generates an image for me. And the only similarity between them is that they use similar kinds of like neural networks in behind the scenes. But because both of these sort of hit starting in kind of like 2023, right? Late 2022, 2023, they kind of became like impactful enough to really make an impact on the world, that we just sort of cluster them together as like generative AI.
Have you ever used the Microsoft Designer? Do you know
I
that?
haven't, no,
It's
but
really
I
cool.
have seen some videos. Yeah,
Yeah, I mean, I was
yeah.
blown away
Did
because
you use it?
yeah, in my last podcast, usually what I do is, and I'm going to ask you for it later, a little picture of you, and then I remove the
Yeah, sure.
background. And I used to use Photoshop for it, but now I saw it. Oh, they have a background remover in Microsoft Designer, so I clicked on it and said remove the background, and done. And
Wow.
but it can also do all the other things like generate a birthday card for my daughter like this, and so it's pretty
Yeah,
cool. And it's so I think it's free. I'm using my personal Microsoft account, not work, but my Hotmail account to sign up for it and play with it. So it's pretty amazing the stuff and there's more coming soon. I'm pretty excited. For all these
yeah.
things
No,
that are
I
coming.
think you're totally right. Like this is changing industries left and right. And I think people, I don't know if you've seen like the video generation. Like I think video
Mm.
generation is kind of where like image generation was like maybe like 4 or 5 years ago, right? It's kind of like, yeah, I can kind of see a semblance of this, but if this continues along the same trajectories, we'll be able to like generate videos in a couple of years. That opens all up very different kinds of use cases and the kind of like movies that people might be able to make with this is like, yeah, it kind of blows my mind to think about.
Okay, so let's go back to Fabric. So what kind of copilots
Yeah.
do we have in Fabric? And let's start with the area that you're working in, the data science world. Like what are some of the copilots? And again, here we have to be a bit careful. I don't know, you're probably already working on some feature that we haven't released or announced yet. So we have to talk
Yeah,
about
of
what's
course.
there today. But what kind of the stuff that you're working on today and how does that then work?
Yeah, so the three co-pilots, well, the idea is that you will have like the Fabric Copilot, right, which will help you with all of your data tasks. And the areas where you can use that right now are Power BI. There'll be a Copilot there. The data warehouse, data factory, and the data science, data engineering notebook Copilots. And I've been most involved in the data science, data engineering Copilots, so I'll probably speak mostly to that.
Yeah.
Um, but those are the three big ones that the experiences that you can use right now. And the way they work is according to very similar principles, right? So if you go to a notebook right now and maybe you've never used Python or used notebooks before, no worries. You can go in there. I think we've rolled out by now to the whole world, so you do need to be on the right capacity. But if so, then you can click the button. It says Copilot. It'll pop up on the side. That Copilot then has an understanding of what you currently have, like the lakehouse that you have associated with your notebook. And if there's any data there, you can now load that in. So you just ask it like, hey, can you load in these files? And it'll generate Python code for you because it is able to know what you have access to. And then you can press the button and execute it. And now suddenly you have, the beginning of like you want to ask questions, ask it to make various plots, ask it to do some statistical analysis. Or my favorite features will be like, can you come up with some suggestions? What are some good ideas of like what is in this data? Like what can I figure out? And it'll come up with some actually
So
very reasonable ideas.
let me ask you because
Yeah.
okay, and I'm kind of thinking about this the same thing with the Power BI Copilot. Is how does it know about the data itself that you have sitting inside of the lakehouse? Does it actually look at the data itself and learn from it, or do you use a model that has been trained before, and then it says, okay, these are the parameters that the model is, and then learn from that?
Yeah. So you have to. This took me a while to kind of like get out of my brain, but the idea of like we're not really training these models anymore. So once we have the OpenAI GPT-3 or 4, you don't sort of provide it with more data so we can update the model. The only thing we do is that we add information to the prompt, so the text that we send to these large language models. So if you want to be specific about it, if you have data in the lakehouse that you've attached to your notebook, then in there, what we will do is like, we would tell something to the LLM like, you are a helpful data science copilot. You have access to the following data sets, and we just literally go fetch the names of the tables that you have in your data in your lakehouse and the names of some of the files in there, or at least some of the folders. And then we add that there, and we say the question that the user asked is, and then we just take the question that you have typed into the question, and then we say like, and the things that you can do right now are generate Python codes, in which case you can do a special character, and then write the code, and then we have a little system that parses that and takes it away and actually executes it, or imports it into your notebook. And we still allow the human to actually press the final like yes, do this button. Or you can find more information in the lakehouse, or you can find more, right? And we have a few of these sort of skills. But the core idea is that we just literally just paste that information into this text, like this string.
It doesn't actually know anything about the data. It knows the metadata.
Oh, right. Yeah. It does know about the data, depending on the circumstance. That data doesn't get logged by us, right? So we don't do anything with it, and it stays within Microsoft. That's the other important thing to note here. Turns out it's very hard to get these systems to perform well if it never looks at the actual underlying data. You kind of want it to be able to see what is in some of the columns, so it can help you do some of the analysis.
Yeah.
That is dependent on the use case. Like we try to use as little as we need. But it is often very helpful.
If the more data you put in, the bigger the model gets, the more CPU it's going to take, or GPU, or whatever we're going to call it. The more processing power is going to take.
Exactly.
Right? So.
Yeah. So this idea of like, how do we make the prompt as informationally dense and useful as possible, while not adding like too much information so that it becomes too expensive and slow? Is sort of like the key trade-off here. So it's a very different way of thinking about AI than we used to, right? Where we kind of just give it all the data we want. And here it's more about like, how do we select the right information at the right time and make that available to the AI to sort of reason over.
Makes sense, yeah. And but by the way, this is how I learned to write Python, by telling them, here's my SQL, write it into Python. And then GTP did it for me, so.
Wow, and yeah, was that effective for you?
Yeah.
Yeah, and just to sort of maybe double down on that idea, like we've been getting emails from people like unprompted, just telling us like, wow, this is such a game-changing technology. I've always been intimidated by Python. I've never wanted to really use it. I don't really know like how to get started on it. But now I've been able to use this CoPilot to help me just debug and come up with like, how do I even approach this or start with this? And you can go very far. And it's kind of amazing how much this kind of technology can reduce the barriers to entry for a lot of very powerful technologies, right? I've been able to code in languages I've never written before, just working with GPT-4, and it does an amazing job. And it's if you haven't had a chance to try it, to your listeners, like I would highly recommend just giving it a shot, because it is.
I mean, I must say, even for myself, I really try to get into the habit of using it more myself too. Yeah. Even for my day-to-day tasks, instead of Googling it or bigging it, whatever, I now use the Bing CoPilot most of the times to ask questions.
Yeah. And how's that experience been for you?
I think it works really well. Like I was telling you in the beginning, like I was just researching for running, which heart rate zone should I be in? And I was searching for it before, and I couldn't really find a good example. So I thought, okay, let me just try and ask the CoPilot that is sitting in Bing, like, okay, what should I do? And he said, okay, you should probably do this because you're a beginner. Like you're not going to run marathons, so this is the best for your age, and less injury, so you should run zone 2, 3.
Yeah.
Okay. Great.
Yeah, that's very powerful, isn't it?
Yeah.
I do want to call, like, for a lot of these use cases, like that is a very powerful way of like interacting with these large language models. You got to be careful of you might have heard of like the term hallucinations, those sorts of things.
Yeah.
I think you got to be careful to not overly rely just on the LLMs, because you shouldn't treat them as oracles. You should treat them as reasoning engines. So the way that a lot of these systems work is that they do a good job to try and find information from various sources and then use the LLM to distill it and to provide that information. So if you're using it with Bing, it'll look up, right? A lot of these examples
it
from
also
the
tells the source.
Yeah, exactly. And that is the kind of habit that you should get into of like using it, right? You can go to ChatGPT and they're like just the base ChatGPT won't use any sources. It'll just like kind of regurgitate it from memory. You got to be a little bit careful with that. But using tools like Bing or Perplexity AI is another one of these like search engine examples. They do a great job of like finding sources that are relevant and then summarizing them for you, and then it becomes much more trustworthy and much more actionable. Like I found it very helpful to then be able to ask questions over the examples if I don't understand it, right? If it's a little bit too technical for me, it does a great job of sort of like simplifying it for me in terms that I understand. Yeah, great use cases for it.
And then, so let's go back because this kind of ties into another question I have here about the like concerning parts about AI, right? Like Skynet taking over, or we're going to lose all our jobs. And so I know at Microsoft, we talk a lot about responsible AI. And even I know in our engineering teams, like this is something that is on top of mind. Can you talk a little bit about that? And what does that mean? And
yeah, so I think there's a few different ways to grapple with that question. I think in general, we're probably right to be concerned about the power of AI because it is such a powerful technology. So definitely we should go into this whole conversation with eyes open, and we should be discussing like how far do we want to bring it? What are some of the implications of this? And can we control it? I think there are some legitimately important questions to ask, that if we get these AIs to very powerful levels of capability, can we still make sure that it will do what we want it to do? We're not there yet. And I would say that we're pretty far from that. But in the meantime, there's also many other kinds of issues. Like, turns out the internet is not always the best place to learn and grow because it is often very toxic and vile. And in many ways, these large language models are sort of a mirror of that data. So they have mirrored some bad biases and such. And there's a lot of work that needs to be done to make sure that the products that we build don't propagate that kind of information and that kind of bias, because that is not a world that I want to live in. So you can kind of like have this conversation on a very direct, like what is happening right now, and more in the abstract, like future. I think it's important that we're thinking about both. Like, once these systems become very good, are we going to start automating jobs? And what does that mean for our economy? And are we okay to absorb that kind of shock to the system like very quickly? Because it's probably going to hit, once it hits, it'll probably hit very fast. Yeah, I do have concerns about this. I'm glad that at Microsoft, we take that quite seriously. So we most of my job actually is in trying to make the systems reliable, safe, transparent sort of things.
I'm just looking up because I recently read a book from Mustafa Sulaiman, The Coming Wave. Have you heard of that? It's really good. I'll put the link in the description. It was a really, really amazing book about talking about all of these, and I think he's a bit more on the negative side. He's very concerned about some of the things that are possible, but I was talking about, I don't know if you've listened, but there was a recent podcast, I'll put that in the description too, about with Bill Gates. It's on one of my favorite podcasts that I'm listening to. It's mostly about politics, but in this case, they were interviewing Bill Gates. And he was saying, because of all the work that he's doing, like, in Africa and places like this, he's saying it's just such an immense, like, kids who never were able to go to school, like, we can create a tutor for them, based on this is how you should learn. Without, like, the only thing they need is a little device. And it needs an internet connection. That's it. But now he has the best teachers in the world. So it's quite interesting. It's quite an interesting experience. Yeah, so this responsible AI is really thinking about it and making sure we're good with using the right data. And is that it, or how should I?
Yeah, I mean, a lot of it has to do with like sort of the baseline levels of security and privacy, right? Like your data is on Fabric, that the expectation is there that that should be safe. And even if we start using some of these large language models, that guarantee should remain, right? So there's a lot of work that we do to make sure, like, are we not passing information that we shouldn't, that we want to make sure like gets protected in the right ways. The large language models that we use on Fabric stay within Microsoft, so that helps a lot. So we have many guarantees that we can put around that. So that's like first and foremost, right? Yeah, some of the other things are like at some point we're going to get these systems to try and make them take autonomous actions, right? So that's the trend that people are pushing for, both from the technology side because it's exciting, and right, OpenAI is very much like starting to work with these GPTs that take actions and do things. But also our customers are saying like this will be a game changer, right? We really want something that can sort of like help us automatically like find information and answer questions.
Okay, can you give me an example?
Okay. Of the latter, of the kinds of like situations that. Yep. Yeah. So for instance, we're working with some teams that are, and I need to be careful of like how much I can tell. But yeah, we've done many conversations with people, for instance, who are they've got sales reps and servicing people out in the field, and they often need quick access to data, but they don't really know how to write SQL, or they're out on a tablet, and it's hard for them to get that kind of information. And a dashboard kind of gets them pretty far, but not all the way, because they're often like a little bit more flexibility that they need. That is hard to sort of program into that, like into a dashboard. So the solution for that is that there's an analyst back in the office who they will like text or like message via Teams to be like, can you find me this information? And then there's like a few hour delay because that analyst has too many other people that they're servicing, right? And eventually finally they get an answer, and sometimes it's on time because they're still on site, and sometimes it's too late. Wouldn't it be great if instead of such a system, we can get the analyst to provide the AI with some examples and with the right data sources, and provide some additional contextual information that they know like it requires to like really write the right kind of SQL, and then have these large language model ingest that information and like the field agents kind of questions, generate SQL, like make sure it all looks okay, and then send the answer back, and you get an answer in seconds rather than in hours. Right? Like that kind of use case of making data-driven decision making like available at the fingertips of everyone in your company, like that would be a game changer, because suddenly everybody can be very well informed, and we don't sort of like, right? There's this idea of like democratizing data has been an ongoing like conversation and like target for a lot of these like SaaS companies like Fabric, but they're still missing that key part of like you still need some tech skills to actually make that a reality, and LLMs might be able to fill that gap. And yeah, that use case and many very similar ones like it, like yeah, we're getting lots of interest around.
It's quite interesting because like there's so much things that we can start doing. But so what about the interesting thing is, so I told you before, right? I used to use data mining add-ins in analysis services a long time ago, 2010. We didn't have anything like this. But back then, and I think that was the problem of that product in time, nobody trusted it. Like I was able to do, like I was at a company and they had a massive problem. They were doing forecasting the same way for the last 10 years by hand. Based on like, this is how they would do it, and this is how we would go. And then one year I was sitting in the office and some manager came in and said, we did completely the wrong thing. Forecast is completely screwed. We lost $1 million or something. And everyone was scrambling. Then I had the data in the model. So I ran the forecast of that same data with my algorithm, like it was built in, and it was like spot on. And I showed it to them, but they didn't want to use it because they didn't trust it at all. Yeah. But I see this completely the reverse now with GTP. Everyone trusts it. We talked about this before. Like everyone who actually knows the stuff, like you, says, well, like take it easy. Like verify your sources, see how it's going. So how do you see that?
Yeah, great question. Very nuanced question. I think we're right to be skeptical of some of these systems. I think that's always going to be healthy, especially once you start making very mission critical decisions with this. like that there should be a baseline, baseline kind of like, does this make sense? Can we test it? Those sorts of things. So a big part of like what I think it will take for this technology to mature is how do we do evaluations? And I'm starting to see, like, last year, I think some of the people who have been working in AI for a while kind of like realized this and started working on some tools. I think this year I'm starting to see that already much more. We've only been 2024 for 6 weeks, but I'm actually kind of seeing kind of a shift already. That people are much more interested about, like, okay, great, we built this prototype, it does a bunch of useful things, but how do I actually know? And how do I make sure that it doesn't go outside of its bounds? And there are ways to test that by just putting this into the hands of the people who are capable of evaluating this, right? Who have like the technical skills. Like, if you are an analyst and you know how to write SQL, get it to write SQL for you and then verify that it's actually answering the question your way, right? Like that's something that we definitely need to do. And then I think we also still want to, right, like adding sources, providing like the reasoning, right? Just in the same way that I might not trust contractors off the bat, right? Some I've never worked with before, and I kind of like outsource some task, and then I start working with them. It takes me a while to sort of build trust, and at first I'll probably like look at their reasoning in a little more detail and kind of look at the general quality of their work. But over time, like I learn more and more about what they are capable of and what they aren't.
So this is interesting. You said look at their reasoning. Like, how do we look at the reasoning?
So, for instance, you can have it. It's interesting. You can have it like output the code that it used to generate your answers, right? So you can like look at the raw SQL code. Then there's tricks you can do. If you don't speak SQL, you can get another LLM to just answer like, hey, what does this SQL do? And it's usually like oftentimes it's better at criticizing itself than providing an answer. So that's kind of a weirdly magical part about large language models as well. Like if I use GPT-4 to generate some code, and then I ask GPT-4 again, like, hey, here's some code, here's the question, like, is there any mistakes in this? It'll oftentimes find some of those mistakes and then fix them. And say, well, why didn't you just do that from the get-go? And it's like, well, I don't, like, it's hard to kind of figure out, right? But like, right, there are some of these tools that you can sort of like self-referentially like use. There's also some sort of like classical tools that we can make sure that we can use to make sure that you're not, for instance, like deleting or removing data that you shouldn't be and making some permanent like action, right? And then the other thing that you can do is the more sophisticated models out there or the more sophisticated like CoPilot systems using GPT-3 or 4 or something like it, they'll have planners. And at some point what they'll do is like, here are the actions that I'm going to take. And you can show that to your customers and saying like, great, first I'm going to go find this information here. Then I'm going to run this kind of like, I'm going to load this data in here. Then I'm going to run this kind of statistical test. And then I'm going to look at it, right? And if you just take that out and kind of like, here's what I'm doing right now, that also provides a lot of information about like, build some trust. But like, oh yeah, these steps make sense. And it's learned like the reason over this. So it needs to be like some transparency, some like, it can't just be like, I'm working on it, here's the answer at the end. Like once you can kind of like double click on something, initially I think a lot of people will be very interested in doing that more. And then over time you kind of learn about like, oh, a lot of the basic things, like it'll probably do fine. And some of the more sophisticated things I might just want to double check. And that just needs to be built into a lot of these like Copilot systems.
Makes sense. And then we're kind of running out of time, but I keep coming up with more questions. I keep coming up with more questions. So what if we like we were working with GPT-4 today, but
yeah,
like, I don't know, by the end of the year, I have no clue. We are GPT-6 all of a sudden.
Yeah.
Your answers will change. So how do you build like mission critical systems when like there's two variables that are changing? The model can change, data also changes. Will you get different results? Yeah. How does that work?
Yeah, great question. I mean, for some of our own copilots, we've had that happen a few times, right? So GPT-4 by itself, for instance, is not just GPT-4. There are multiple versions of them, and they get updated. And sometimes it was able to do some things, and then like suddenly it's updated and it's using it gives other answers. And like, how do we deal with that? Or right, like recently, the OpenAI came out with GPT-4 Turbo, which is similar to GPT-4, but significantly faster and cheaper. So we would probably want to switch over to that compared to using GPT-4, because it's just, that cost quality trade-off seems to be like quite good. But it is different. So like, how do we do those tests to make sure that we can like sort of upgrade that system around like everywhere, right? Yeah, you need the infrastructure to make sure that you have like solid tests, to make sure that it does make sense. It still does the things that you want it to do. And the hard part about that is that is very different to how in classic software engineering you're running tests, where you just, you write a unit test, you know exactly what the input output should be. Or in machine learning, what we were talking about before, you have that holdout set, right? And you kind of say, I want to test on this. Like it's kind of a big outstanding question right now. But the way that we solve it is we do a combination of like manual testing ourselves, just to make sure. There's always going to be like that human that just makes sure. And then we have just a battery of tests to say like, here's a bunch of tasks I expect you to be able to do. And does it actually execute it? Does it give us the right answer? But you got to invest in those systems. And I suspect that whoever is going to be building with these large language models, you're going to have to do something similar. Don't take the evaluation like as easy. On the bright side, if the jump from GPT-3 to 4 is similar as from 4 to 5, it's going to be very much worth it to make that transition. Maybe for simpler problems that you need to work on, like doesn't really matter. But for some like the planning stuff and the deeper reasoning, GPT-4 is significantly better than 3. So that investment that you're putting in to upgrade is going to be well worth it.
So, and maybe let me ask you, because something else triggered you. And all the way in the beginning, you said you started working in sustainability. But sustainability and AI, does it really go together at the moment?
So I think there's these arguments about like these large models. They aren't really like that. They're energy intensive. They use a lot of like water to cool like the systems. I think if you run through the math, it's like it's pretty like the numbers initially look dramatic, but in a larger scale of things, like I think they're more manageable. I also think that one of the best ways that we can solve some of our sustainability issues is by better materials, by coming up with better photovoltaics, batteries, biodegradables, those sorts of things. That was initially why I was drawn to AI and materials. And I think some of the things that people have been able to come out with AI is, that is going to fundamentally change the way we do material science research. And I think it's almost going to be impossible to come up with some of those materials without AI, honestly. Like the problems are very hard, and then we need to come up with solutions fast. So
I can imagine.
I think it's a hard kind of interesting problem to talk about, but I think the other thing that's interesting is that the incentives are aligned there, right? Like one of the biggest problems of AI is that if you want to train more, heat dissipation and energy use is sort of like the big problem. So you really want to use cheap electricity. So a lot of these like Microsoft and such will invest heavily in renewable energy and like work like close to hydropower and such. So they make big pushes for that. That is often far away from like cities and stuff, so that electricity is hard to use in other places.
Makes sense.
But yeah, I do wonder, because like, I don't know if you follow that news, but Sam Altman came up with that idea of like, I want to spend $7 trillion on like chip fabrications, right? Which is like an insane amount of money. And I think someone ran through the numbers about like that would use like some crazy percentage of our global energy usage, right? Like something like 10 or 20% or whatever it is. That doesn't seem something that's very sustainable at all. So I think we need to have a conversation around like, what as a society do we want to prioritize here?
But it's pretty cool. There's amazing stuff. One of my favorite articles, and I put it in the link of the description below. Last week, I don't know if you've seen it, but my passions is history, and they were able to read like four books that they found in Pompeii, in Herculaneum, that's next to Pompeii, that was petrified, and they were able to read it thanks to AI. And the way that they did it was mind-boggling. It was really amazing. I'll put the link in the description. So what? As last question, because we're really out of time. Last question: what are you most excited for going forward with AI? And it doesn't have to be
so many things
in general.
Sure. Yeah. I mean, I love the idea of doing education for everyone. I think that is going to, like, if we get everyone more informed and able to think cleaner and clearer and better, and sort of understand the world that we live in, like, that's going to be just better for everyone. So I'm very bullish on that. Love that, people like Bill Gates are working on this. Material science and AI, also a great place, including like medicine. I kind of see that as like a similar kind of problem, like these big hairy problems where we don't really know exactly how to solve it, but AI have been able to like sync through it, like cut through the noise and come up with some kind of great breakthroughs. I think there's going to be more to see there. If I had to pick anything that like is maybe a little bit different, there's this crazy research that I heard about 8 months or so ago about people trying to translate animal sounds. So they take something like whale song and they realize that there is like kind of like grammar and structure and vocabulary there. And there are AI techniques that people are using to, in the same way that you can like translate English to French, like the way you do that is you kind of find a few key phrases and then you have the structure of the language that the AI is able to like understand in English, and you have the structure of language that is able to understand in French, and you kind of map them to each other and just sort of like align them. And people are trying to use that same technique for animals. And I think if we are able to communicate with whales and have a conversation, I think it'll change the way that we think about our place in the universe. And I think it's a very powerful application potentially of AI.
I actually once heard a whale song on the water.
Yeah.
It's amazing. Like, first I was thinking, what the hell is that? Like, it's just such a big noise,
yeah,
big sound, and then figured out it's whale song. It's just, yeah, I can totally imagine. All right. So
yeah, it hits deep, right? Yeah.
It did. So thank you very much. Love to get you back, like maybe when we chat GTP 5 is out or whatever, talk more about this. But
love it.
I learned a lot. I hope our listeners also learned a lot. Thanks so much for your time. I'll put a lot of the links in the description below. But Alex, thanks a lot for your time.
It was my pleasure to be here, Kasper. Glad to be on next time.
And that concludes another episode of Kasper On BI. I found it very exciting. I learned a ton about AI, LLMs, CoPilots, how they work, what they can do, and so on and so on. If you like this, hit the like button. If you want to learn more about other topics that are coming up, hit the subscribe button, and so you can always get up to date with the latest and greatest. I put all the links in the description below, so for all the more learning that you want to do. With that, a good day, and I'll see you next time.